Good afternoon and welcome to the stream. Feels like forever since I've worked on the Zoxbox, but today I have the Zoxbox on the bench. I have the instructions in front of me and beside me, and I have tools that usually are not on the workbench. Now, of course, you're probably thinking, oh, what could you possibly have that's not normally on the workbench? And that would be a coping saw. Yes, because as you might have seen, there is an assembly step that I need to do before I solder, and that is I need to trim these down to length, because it's a lot easier to do it before you solder than after. And I was looking at my coping saw, and the blade that is on it is really coarse blade. So let's go for a fine blade so we get a fine cut. At least that's the theory. And of course, probably help if I read the directions. Well, now if you twist this long enough, the blade should just pop right on out. I don't know how old that blade is, but we're going to put this nice brand new blade on it. It is I think it's an Irwin blade, whatever I picked up at Blue Box. Which, if you're wondering what Blue Box is, no, that is not the name of the DVD. Well, I guess maybe it is the name of the DVD rental boxes as that particular department store. That is also, if you will think of the colors of your various home improvement stores, one of them is blue. They are not a sponsor. But, well, if you need another hint, there you go. There's another hint. Because there's also orange box. And then I have no idea what color the crazy guy box would be. Green, maybe? Green and orange? There's none in this particular area. But yes, they're not a sponsor, so they're just going to be Blue Box today. Picked it up there because there is no orange box locally. All right. So, the first step that I need to do, while not mixing these up, because that will cause problems later, these need to be trimmed down to the length so that they match lengths, with a caveat that it's not the length of the shaft per se, but they need to match lengths so that the top of the shaft is going to be in the same place when you put these in the case. So, in other words, it's not like the shaft length, but it's the total length, but trimming the shaft down. Now, I'm pulling these all out because I do not know which one of them is the shortest, although I believe... okay. I believe I did just find an out, and that is that it says to trim all the potentiometers, and I believe this is a rotary encoder. So, all right. So I am going to literally take that to mean just the potentiometers, and we'll put that encoder back in its bag. Set it back to the side. Okay, those are encoders, so I don't need to mess with those. All right. And let's see, this is a potentiometer. And these are last two. All right. So looking at the collection of potentiometers I have, it would appear as if the shortest one, and I'll go to the screen here. And it is, as you will note from this fine picture here, that it is, we would want to trim here so that the tops are the same. You'll notice we don't want to fall for the trick that some of these potentiometers, the base is taller. So if we just matched the bottom where the shaft starts, it won't look right. So we need to match the base. But it does appear as if this is the shortest one overall. I will double check. Yep. Okay. So the only ones I need to trim are all right. So these two here are the same height, or they're so close that I'm not even going to try to trim them. But these 5 are taller. So what I need to do is I need a marking blade, because I don't think I have a marker that will work. I will use I think I will use that one. So I'm going to put this one back in the bag so that I do not mix it up. And I'll set it back over to the side. All right. And also, I'll go ahead and put these in the bag so that I don't mix those up. So I do know that, let me just make sure that there's some sort of marking. A1, okay. Yeah, all right. So there is a marking on the end of this one that says A1M. And if I just remember, that stands for audio 1 mega ohm. I should be golden. All right, so what I'm going to do very carefully is I will hold 2 of these alongside each other. And then I will make a slight mark that will be dark enough for me to see. And let's see, I will do the same thing to this one. And all right, I just need to mark it just enough so that I can start cutting it. There we go. All right, so I have a slight mark on those 3. And then what I will do is go back so I can see the directions. Now it does say that we want to hold the potentiometer by the shaft and not the body. That is a very important step. So I'm going to use a pair of pliers that should not leave, I mean, it won't leave much of a mark. We'll hold that. And I'm going to line up my coping saw. And voila. And then I will not cut all the way through, but there's such a little bit left there. I am just going to trim it. And then I'm going to realize that I forgot to grab a small file from my tool chest in the garage, and we'll correct that mistake momentarily. All right. Well, that one actually is all down more or less completely. Let me just double check. All right, those are, yeah, all right. I think I kind of missed the mark a little, but it's not significant. I won't worry about it. And lastly, well, I know I drew a line on all three of these. Oh, there it is. Okay. I need to make my mark a little bigger so I can actually see it. There we go. And all right. Oh, all right. So there, those three are more or less matching. And all right, two more. This time I'm going to make sure I mark them on proper side. Hold these up beside each other. Little line on it with the knife. Try to make it just a little deeper so that I can actually maybe the saw blade will catch a little better. All right. And then put this one to the side. Oh. And I will put these 3 back over here because I need to file them. All right. There will be knobs on these, so if they're not perfect, the knobs will cover it. All right. And one last one. I mean, there's not this fine blade actually is doing a pretty decent job on this plastic. So there's not too much I need to file, but I do want to make sure the knobs will go on nice and smooth. So I'll go up to my tool chest and grab a file. And the whole reason I'm doing these all now is just because I should have done it earlier. But the voltage controlled oscillator circuit, we do need to put one of these pots on. I don't know that it's one of the ones I need to trim, but it's better to trim them all down to the same length at the same time. Because then I only have to brush the mess off my desk once. All right, well, all I needed the coping saw for, I could actually go take it up to my tool chest. It's actually not a bad idea, because it does not really belong down in the garage. Close my knife, because that's always a good idea. And it might as well. Yeah, I brought a trash can downstairs finally. So now I can actually throw trash in a trash can, or brush my desk off into the trash can. Because I had it full of papers that needed to be shredded, and those papers just kept accumulating. So actually, I figured out that you could take papers to the UPS store for shredding, and they charge 99 cents a pound. So fortunately, I had only 3 pounds of paper, but that was way easier because they actually have an industrial shredder do it, and I was able to put several items in the bin that to put through my shredder, I would have had to have pulled staples out and torn them up and fed them through small chunks at a time, whereas their shredder will just eat through it like nothing. So I consider that $3 well spent, and it liberated the trash can for the basement. All right. Well, let me go upstairs and grab a file really quickly. So I will be right back. And I will put some music on so that you can listen and enjoy it. Should not take me long. I know exactly which drawer the files are in, so I'll be right back. And I'm back, and I have a file. So I'm just going to go ahead and clean the tops of these potentiometers up. All right. Get them close. Basically want to make sure that the edges are smooth so that the cap will just go on. With the fine blade on the coping saw, there's really not much to clean up, just a little bit of cleanup work. All right. All right, so those I do not believe are the ones I need for this. I think for the voltage controlled oscillator, I actually need the potentiometer that I used as my guide. Also, I will have to add that once I put the potentiometer on this board, I will probably be annoyed while working on it, because potentiometers get soldered to the opposite side of the board than all the components. So, well, at least I have a quad hands, because I will need the quad hands for future soldering as soon as I put the first potentiometer on the board. Yeah, it was confusing me at first because I was trying to figure out, because there's a mod on the that I'm going to do during assembly. So one of the potentiometers I have is different. It's an alternate part. And at first I was thinking, oh, well, the voltage controlled oscillator must not use that potentiometer. But the more I read the description of the mod, I'm like, where I think this potentiometer goes doesn't make sense. Then I realized the potentiometers go on the backside of the board. And then I realized, oh yeah, the voltage controlled oscillator does use the alternate part. All right. So now our potentiometers are all the same length. And good to go. So I'm going to grab this. Oh, I can move my paint samples over. I don't even know why I brought those to the basement, because those paint colors are not for the basement. But whatever. All right. Let's see. We don't need this board. But I believe I'm going to find that these are the parts for the voltage controlled oscillator. Oh, that's weird. And I've got some resistors that are down in the bottom of the bag. That's annoying because I don't know what they are. Huh. Yes, I know I could measure them. However, there are some resistor-like items in this batch that I suspect those are actually what those are. So even though there's stripes on it, I think it's a... I don't know that that's just a plain resistor. All right. So let's double check that I have all the parts that I'm supposed to. So for the voltage controlled oscillator, I should have a toggle switch. Yes. Have a toggle switch. 1N4148. I'm pretty sure I have. Yes, 1N4148. 2.2K resistors. Yep. 10K resistor. Yep. 22K resistor. Yep. Looks like I took these out of the in order. 100K. In order that they're on the parts list, that is. All right. 220K resistor, yes. A 1 meg resistor, yes. 24K. 24K. Yes. 200K, yes. All right. A 5K trimmer pot, yes. A 50K trimmer pot, yes. A linear potentiometer. All right. So I actually marked on the potentiometers which one goes to which. I'm looking for the one that I have marked VR2. That one's marked VR2. Wait a minute. I need to go. I have one more potentiometer to trim because actually, that's the one for VR2. I forgot where I put it. I put it in with the rest of them. All right, so I need my. And actually, I'm going to cut this one differently. So this one, I'm going to mark. All right, so you're supposed to also be able to just cut this with side cutters. So I took my coping saw upstairs. Of course, I would. So, because I'm likely to make plastic go flying, which might actually be fun to watch. Let's see here. I'm just going to try to trim this with. There we go. And did an okay job. And of course I dropped it. Well, not sure where I dropped it to. Oh, well, that was a lucky catch. Fell into the box that I had sitting under the table. All right. Actually, that looks pretty good. I would like to clean that up just a little more. There we go. That looks good. All right. So we've got our audio potentiometer. This one has a center detent. That's what's different about that one. Because that's the tuning potentiometer. So one of the mods is to use one that has a center detent to help you get back to centered. All right. And then I should have two 1K PTC thermistors. Which I believe are those. Now this is where I wasn't quite sure. Okay, so these components I have floating in the bottom of the box, I believe are the 1K PTC thermistors. They have the same stripes. Black, orange, red, black, brown. As the picture from Lady Ada. So I could use those. But I also, because those came from an eBay auction, I did buy some PTC thermistors that are, they're actually glass. I think these might be higher precision parts. So I may use those. I don't know that it really matters. All right, and then I should have some poly caps. See here, it looks like I should have a 0.001 microfarad. Yes. A 0.01 microfarad. Yes. And 0.22 microfarad. Yes. Looks like I should have some 1 microfarad electrolytics. Yes. 10 microfarad. Yes. And all right, a 4066 analog switch. Yes, I got that. A 74 AC 174. Well, I have a 74 HC 174, so I'm hoping that is going to work. All right, 2SA 733P. Yes, I've got those. I believe I also have some that are the ones that I set aside. Yeah. So I'll have to look and see if any of the, well, actually, considering I put that little bag in this bin, that may be an indicator to me that at least one of those transistors needs to be one of the binned ones. Let's see, two SC536Fs. Yep. And two SK30. All right, I got those, and I'll have to be cognizant of which type. To an AN6562, got that. And 2SC1583. All right. Well, with that, I have all of the components that I am supposed to have for this board. In addition, I have the board. And take it off that. And I have my soldering iron and a new thing of solder. I've got flux. I have some bigger solder wire, should I need it. So all this soldering is going to be in this quadrant of the board. I'm looking at the picture correctly. Yeah, it looks like it's all centered in here. And in fact, yes, I believe these 3 sockets are going to be the 3 sockets that ICs go in. So, those power wires. Okay. There are some power wires that I should have running from the I/O board to this board that I forgot about. I need to find some wire. Okay. Well, that can wait until later. I found wire, but it wasn't... I didn't like the gauge of it, so I'm going to have to actually go through the instructions, because I don't know if the wires that they have you solder during the assembly are the ones they expect you to keep or not. So I will have to look at those instructions and figure out what to do. All right. Oh. It would also help if that's weird. Why is the fan bound? Huh. Oh, weird. The fan was caught on something. I don't know what. I can't tell. Alright, so I've got my little smoke absorber. Alright, since it's been a while since I last soldered, I'm going to take a moment and do a little cleaning of the tip. And then hopefully put my arm on the components that are about to fall off the table so that I don't have to go chasing them. Alright. So the solder tip is tinned. It should look good. Let's begin. Alright. Solder in the following parts. Diodes D25, D30, and D31. Alright. Let's see if I can liberate my printed instructions, because I think I left myself some notes. on yes, I did leave myself some notes, which is excellent. So D25, D30, and D31 are... well, I believe I will find that I only have one type of diode in this pile, and that is the one N4148, and that is the type of those three diodes. And as I solder these, as I take all three parts, I will put them back in the bin. So, and I will also check things off on my instructions that I have printed just for reference. So hopefully if I miss something, I will notice. So D25 is here. And we want to make sure the stripe lines up with the stripe on the silk screen. So D25. All right. D30 is right here above this IC socket. Or well, if you're assembling this, it'd be IC11. And D31 is right below that. D30 and D31, the diodes go in the stripe goes in one direction on one and the other direction in the other. So, all right. And I'm well, can't get this component to there we go, that's a little prettier. Almost. Oh, I'll clean that up. And let me see if I can't. And get these four here. All right. Oh, that looks pretty good. I have actually purchased another lens for my little camera. I actually tried to replace the camera, my overhead camera, and, well, I'll just say that the new camera worked last night when I tried it. Yes, that was if you were watching Dave's Vintage Apple Tech, was the camera I was messing with while watching the stream, and yeah, of course, well, although in this case, it wasn't OBS. Being a meanie afterwards, the camera. Yeah, so last night the camera worked. Today the camera did not work. The exposure was like, I could see that I was getting an image from the camera, but the image was so dark it was unusable. But I could see a glare from my table, so I knew the camera was plugged in, and it wasn't a matter of my like the camera not being plugged in. It was plugged in. 2.2K resistors. Let's see, 104 and 107. So anyways, I guess I'll be returning that camera to Amazon, because it's not good for a camera to just decide to not cooperate. That's not the first camera I've bought that did that it like worked the first time, and then that was it. Every other time you tried to use it, it just way underexposed the image. So let's see, R107 and 104. So anyways, I had to go back to because actually the nice thing about that camera, it had a zoom lens on it. So R104. So you'd have been able to better see what I'm doing, but, well, I can't, Alright, so there's R104, and R107, is, right there, okay. And yeah, you might notice that these resistors are bigger than the pads. Well, in the example photos, that is the case. I don't know why. So that's kind of why I've got to stand the... I can't put the resistors flat on the board. So anyways, that's why I gotta stand the resistors up. Like, well, I know that's out of focus. You know, if I was thinking, which obviously I wasn't, I would borrow the... You know, it's true. I could go borrow the camera lens off that camera. And then at least I could zoom in for today with the camera I'm using, and then I'd make it easier. So how about I'm just going to go do that. I'm going to go swipe the camera lens. So luckily, I think I just set the camera at the top of the stairs, so I'll be back in a jiffy, and I'll have a different camera lens mounted, one I can zoom in and out. So at least I can preview the lens I bought before it actually comes in. So I'll be back in a jiffy or two. So stay tuned. All right, and I can now zoom in, and as long as I put the board here, I can even show you me soldering it too. So now There's the resistors, R104, R107. I feel like I'm actually showing you a more valuable view. Alright, 10K resistors are... okay. Not sure why we only put 2 of these. Okay, there's 4 10K resistors in this section. We only put 2 of them for now. Alright, so I guess I'll set these to the side, but not back in the bin. So R101 and R105. See, that is going to be... there we go. There's R101 here. And R105 is right there. So let's see here. I'll put R101 there. Actually, I'll follow the scheme of the directions. The directions has that one pointed that way. Follow that just in case there's like one of the components would hit it otherwise. There's R101 and R105 is... and up here, and it's right. So all right. So I will see if I can. All right. So there we got R101, R105. All right. That should be fun. Okay. Well, let me mark those 2 off. 101. All right. 24K resistor. R106. There we go. 24K. I have 1. That's R106. R106 is naturally not right beside R105. R106 is beside R104. Alright. Oh, and this one's actually small enough, I bet it fits right down to the board. R106. Yeah, here we go. Well, it's actually... Come on. There we go. Yeah, there we go. R106. In fact, actually, despite the fact that I actually managed to find a component that actually fits the pads and as well within tolerance. The sample picture shows that they used resistors, a resistor for R106 just as big as the others. There we go, R106, beautiful. Well, I think I'd find it more beautiful if there was actually room to put the capacitors flat, or resistors flat, but whatever. Okay, 100K resistor. Alright, so R102 and R118. So I'm only putting 2, there's a total of 6 of those. And we're only installing 2 right now. So it's R102 and So R102 is beside R101. So R102 is right here. And put that the other direction. And R118 is beside R105. Of course. There we go. Alright, and let's see here. That looks good, that looks good. Alright. Let's see here, that was R102 and R118. $200K, R90. All right. R90. Here. Is that right? Yep, okay. All right, R90. All right, R90. Excellent. So R90, although I have a feeling looking at that, I will have a bunch more. Let's see, 220K. 220K is R103. There we go. R103. All right, so it's just one of those. R103 is, let's see here. R103 is right there. So I want to put this here. Yep, it can be hard to see where the leads are, but there they are. Oh, little piece of something. All right, there's R103. Got that one. The thermistors are R100A and R100B. Those, see here. Yep, those go here. All right. Make sure they're still kind of hugging the board. Yep, they are. All right. Ah, beautiful. And yeah, they kind of look neat. Those are the little glass PTCs I bought. All right, trim pots. I'll set the... Yeah, basically, since I don't know for 100% sure that those striped components are PTCs, I'm going to use the ones that I know are PTCs. Trim pots, TM4 and TM5. All right. There's one, and there's the other. So TM4 is the 50K. This one's 50K. TM4 is right here. TM4 and so TM4 is there, and TM5 is 5K. All right. So I will solder one leg of these on. Double check that the pot is more or less level. And it still looks good on the board. It does. Excellent. And then we go. We've got our trim pots. They look different than the sample photos, but they should be compatible. Nothing really special. All right, so we got a 0.001 microfarad. Let's see, this is going to be one of the polycaps. .001 C34. All right, so just need one of these. I think these are Panasonic. Oh, they're Nichicon film capacitors. Okay. Okay, so C104 is... Oh, C34 is going to be right here. And I guess I can go ahead and put C33, which is the .01. Right, and let's see, C33 is here. Right, and all right, well, it's probably good to solder those two down because next item is a different type of component. Right. Beautiful. There we go. All right. The poly caps. All right. So let's see, that was C34, C33, the 2SK30AO. All right, so now I need to make sure, because there are two. Okay, so that one definitely has an O on it. And that one's definitely a Y. All right, so that component. So 2SK30AO goes in Q28. And this is one of the special transistors. So I am going to hydrate before I assemble this. All right. I'm gonna make sure. All right. And it's in. All right. So 2SA 733 Q27. Okay. All right. So I have a note on my paper here. So, this 2SA733P that's going in Q27 does not need to be one of the ones that we tested for a high beta. So I'm just going to take one of the... So basically, if you'll remember in a previous stream, which you can go watch, it's in the Zoxbox playlist, I did beta test the 733Ps that I have. The 4 highest ones that have a beta above 300 are in a separate bag. And the instructions call out somewhere there are 3 of those parts that do benefit from using a high gain. But Q27 is not one of them. However, I think in the next step we will probably install the one of the ones that is. So, all right, 2SC536F. All right, 2SC536F. Let's see, I need 2 of those for now. So the 2SA733P is a PNP. The 2SA536F is an NPN. So let's see, Q24 and Q25. So Q24 is... right there. And Q25 is right beside it. There we go. Beautiful. So, let's see here. Yep, right there. Pointing at it because it's hard, can be a little hard to see on camera. That's why I start soldering it, but I want to make sure it's at least somewhat on camera. Go. All right. And let's see, that was Q24 and Q25. Mark those off. 2SC1583. That's one of the special ones. Let's see here. Those are in a little static bag. No, they're not. Right there they are. 2SC1583. All right. So that should be Q26. Oh, that's going to be a fun one to solder. So basically, this part is I think a matched pair transistor. So it has 5 pins. That have to go into pins that are spaced wider than the component is normally. It comes from the factory, so that's 2 more leads that have to be fed into a hole than on a transistor. Well, makes it that much more fun to insert. Alright, let me make sure that... Alright. Now that looked like it matched the... Just wanted to make sure it matched the picture and the silk screen. I want to say that part is kind of can be flipped back and forth, but I'm not totally sure. Since it is a matched pair. kind of want to, I think the pinout is such that if you put it in backwards, well, it's not backwards. But I could be wrong, so I'll just make sure it matches the picture. And the silk screen. Although it matches the silk screen's kind of ambiguous. Well, that metal pen could use a little bit more solder. There we go. Actually, that could use a little more solder too. And that one could too. Just gotta touch up a few of these that kind of make sure I'm happy with the amount of solder I put on them. Alright, and let's see, last but not least, the dual op amp. IC11. Let's see, IC11 is going to be the AN6562. And nice thing about it is I already put all the sockets on the board, so it's just a matter of wishing I could find my IC pin straightener and putting this chip in the socket I've already soldered. Making sure the notch matches the notch. There we go. That looks good. Beautiful. And so on the other side, solder in VR2. Alright, VR2 is... Alright. And now this probably feels really weird because I'm going to solder the two mechanical attach points. Three Does look like that is down. I'll get my slightly wider solder out here. To make sure that those mechanical attachment points were good. All right, so now we've got our first potentiometer, because when this is mounted in the case, what is the back side of the board is actually what attaches to the, well, it attaches so that all the components are inside the case, so that's why the potentiometer is seemingly on the wrong side of the board. But I think that is partially to, well, it means there's nothing on the side of the board for the panel to conflict with. So, of course, now my board doesn't set flat on the desk. Oh well. But that's the first set of components. Now something tells me if I scroll down, oh, I need a power supply that I do not have. All right, well. All right, so I'm going to add some more components here. So we got another 10K resistor, R34. Actually, I'm just going to go ahead and go ahead and get R36 as well. Let's see, R34. And R36. All right, there we go. Alright, so I got that. 100K resistor. R35. So R35 is right there. So it goes right here. I'm going to go ahead and get these other 300K. So R93. R93. R92, which is right beside it. And R59. R59 is buried somewhere, no doubt. There's R60s right there. So R59 is probably somewhere around it. Or it's... Oh, there it is. Right. Solder those. Right. We got those 4 resistors. 22K resistor. Alright, so R45. And I'll go ahead and get R60 while I'm at it. R45 is, there it is. R45 is over here. R60 is probably, actually I saw it was right here. Right. There's one, and can I get them both on the screen? 1 and 2. Alright. Well, I can just barely fit them on the screen. There we go. Okay, R45 and R60. 0.01, 0.01 microfarad. C10. Okay, so there was just one more of those. C10 is going to be over C10, C10, C10. C10, C10, C10. Ah, it's hiding right here. All right. So I could go ahead and get the 1 microfarad C11 while I'm at it, because I think it's right beside it. 1 microfarad. It's one of the electrolytics. C11. So C11, need to mine so the board is marked positive. Negative is the stripe. So there we go. As to why the one is a polycap and the other is an electrolytic, it probably has something to do with cost. Because I think a 1 microfarad polyester cap would have been more expensive. Quite possibly significantly more expensive. And that may not be doing anything that really, where it really matters. Okay, so I need, all right, here's my bag of bend resistors. Here they are. This is one of my high gain, high beta resistor or transistors. So this goes into Q8. There we go. Q8. All right. All right, and I guess we're going to get these remaining parts, which I will go ahead and do in order on the instructions. Oh, there's those. All right, so toggle switch 1. All right, so that toggle switch is going to go on this side of the board. Well, maybe I should solder the switch on last. All right, I'll get the switch last. Okay, let's see here. R91. R91. R91 is here. All right, R91. I'll put a few components in. R74 to, what are those? Those are the 200K. 16 of those. So I'll have R74 to R89. Well, let me go ahead and get this one resistor here. Since it's off to the side, and I'll... Okay, R74 to 75, 76, 77. Oh, yeah. Basically, I need to solder all of these resistors here. Yay, fun. Alright, well... Oh, I just need to take a moment to insert all these resistors. Not sure what they do, but... the fact that there's 17 of them must mean something. And it could just be that they're like pull up or pull down resistors for something. I'm not going to read too much into the fact that they're being installed in the variable controlled oscillator section, other than they are near an IC that I think I get to insert, so... Oh, they may actually be Because I think actually I just noticed the encoder goes. Or there's a 16 position switch. I think these may be the pull up or pull down resistors for that switch. And it just may be because of where these are, they get installed now because they would be more difficult to install later. And they may be for multiple switches. I don't know. All right, 4 more to insert. V1. That's weird. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14, 15. Oh, did I drop one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15. I sure thought I pulled 16 off. There's only 15 there. Oh. Nope. I did not pull 16 off like I thought I did. Because there were 20 in here and 17, there should have been 3 left, but there was 4 left. So that explains why I ran out of resistors early. There we go. There we go. All right. All right, so I think there's so many of these, I may have to solder some and then clip leads and then solder the rest. Yep. I am purposely skipping some of these leads. I'm getting the ones that are outset, and then I'll clip them and get the ones that are inset. And I'll clip those and get ones that I just couldn't get either way. Clip the leads that I soldered. And then get some more solder. Soldered. That one's soldered. That one's soldered. That one's soldered. These two are soldered. That one's soldered. Soldered. That one's got solder. That one's soldered. That one's soldered. That one's soldered. That one's soldered. All right. Leads off the board. And all right, let's solder some more resistors. That should help me get into some of these here. That one. Alright, I need to clip some more leads because some of them are in the way. Some of those pads I think I'll need to touch up a little bit. I felt like I was soldering the tip more than the pins on some of them. That one's soldered. And actually that one's soldered. And sure, that one's soldered. Alright. That leaves 2 leads. Did not get soldered. Right. Look, some of these that okay. I think that looks decent. There we go. Yeah, alright. So there's those resistors. I'm not sure what that was I just knocked off the desk. Oh. One of the standoffs for the Amiga. Uh-huh. I can attach that. Alright, there's a 0.22 polycap. Alright. That is C35. I guess that's not really going to set the greatest, but alright. It is. Alright. C35. Right, there should be 2 10 microfarad electrolytics, C31 and C32, and those are okay. There's one C31 and C32. All right. $4066. See, that does not need to be soldered. I've got a socket for that. So the 174. See, that goes in a socket. And I got 2 more transistors. Right. So the transistors are Q29 and Q30. It should be. All right. Yep, here they are. There's Q29. And Q30. All right. Let's get those transistors. All right. All right. One more part to solder. That would be the switch. Which goes in. Go. Just trying to see if I can bend some leads on it to kind of hold it in place. I'll try to bend the retention legs. guess I'm just gonna have to... I think I know what I can do. Some solder on the soldering iron. Put the switch back into place because it fell out. And then holding the switch well away from where I'm going to solder. Apply some... Oh, that might not work. Nope, that did not work. Okay, since that did not work, I will go to plan B. I will take some gaffer's tape. I will make a hole in the middle of it. I will poke the switch through the hole in the gaffer's tape. And I will use gaffer's tape to hold the switch into place. Then I will go, and I should just be able to solder these pins in place. All right. And well, that kind of needs a little bit of adjustment, so actually, maybe that is... Actually, I think that is right about... Oh, yeah, I think that is flush with the board. That looks good. Okay, so I can solder the other 3 pins into place. Now that I got the structural pins. I think this is a single pole double throw switch. If I had the faceplate in front of me, I could tell you what it's doing. Switch. Let's make sure I got all the components other than these 2 ICs. All right. Looks like I have all the components soldered. All right. I will... I just have 2 ICs, but I got the sockets already soldered. So I just need to insert them. So this is a 4066 analog switch. I believe I bought one from Texas. This one was made by Texas Instruments. Probably not made in Texas, but That's okay. Do not see a factory marking on it. I do know this is a Texas Instruments chip. So this is going to be IC12. Line the notches. There's the notch right there. And the notch right there. And I need to bend the pins a little more. Right. Try again. Yep. Looks like that's going to just go in the socket now. Excellent. And IC9 should be this chip here, although it's slightly bothering me that I bought an HC instead of an AC. Well, I guess worst comes to worst, I'll just have to, well, in some cases, the response times may have been similar between HC and AC. Quite honestly, even if because I don't know that they make the AC ones anymore. And even if they did, quite possibly they would have been made on the same line nowadays anyway. So there we go. Hopefully the HC will do the same function. All right. That is the voltage controlled oscillator circuit that I will have to test later. So now I can clean some of my desk off. Boy, would I like to put that board through my ultrasonic cleaner. I don't know that I want to ultrasonic clean that board after each assembly section, because that might wear off the, well, certainly by the time I got to the end of the assembly, I would have probably worn off the markings on a lot of those ICs. Maybe I will, well, actually, I probably need to get a can of reflux anyways. There we go. Yes, having a trash can down here. Well, I would have eventually done it, but I'm glad to have one now. Because there we go. That made that so much easier. Well, I guess I can throw that away. That's from where I ran an outlet outside. So beautiful. There we go. So now, I guess if we take a look at what I have so far. Learning, well, maybe the zoom lens I bought will have a better focus range than this. All right, let me turn that light off so I don't completely blow out the boards. All right, so we kind of take a look at what I've assembled so far. So we've got the voltage controlled oscillator. Well, I guess I do need to kind of turn that on, close the iris some. Well, actually, there's nothing there to be blown out. All the components are over there. I guess that works. All right. So we got the voltage controlled oscillator here. We got the power supply. It's looking good for 2 steps. So actually, since it looks like I got a little more time before I'm going to end the stream, let's take a look at something I have over on the shelf behind me. Let's see here. There we go. It's beige. Well, unfortunately, okay. So really, I don't have the right viewing angle, but this is one of the items that got scrapped at work that I picked up. See, make sure there's no. I wanted to make sure I'd pulled the asset tag off of it. I'm sure someone could figure out. Well, I mean, not that you couldn't figure out where I got it, but I like to pull the asset tags off of things that were scrapped. Anyways, this is a leader regulated DC power supply, 30 volts, 3 amps. So it's single output. Looks like you can, it's just like any benchtop supply. Thing is, I do not know if it works. It could have been scrapped for a multitude of reasons. It could just be because we replaced it with a more flexible multi-output power supply. It could be that the regulation circuit is all out of whack and that it gives you a nice AC output between 3 and 30 volts, which would be unfortunate. Could be that there's a, well, I don't know. This is probably, well, no, I guess it could have a reefa cap in it. Maybe it has a reefa cap that blew up. That's the case, Steve. Well, I guess you lucked out that I didn't set this beside you and plug it in and the reefa cap blew while you were beside it. Congratulations. But for all these items that got scrapped at work that I will slowly pull on the bench, I suspect that is what I will be doing some of my winter streams, is pulling some of the items out and occasionally taking a look at them. But anyways, before I plug this in, I figured I would like to open it up and inspect it, because, well, all right, well, the first thing I see is this thing has a big transformer in it. The second thing I see is this cap here, and there's brown goo on the board. Now, the thing is, that could be the glue they put in place to hold this capacitor for soldering. It could also be that the capacitor, well, that's probably glue. I hope. All right. Also, this thing has not been plugged in for quite a while, so. All right. but it does appear to be in good shape. Okay. It is correctly set for correct voltage. You know, quite honestly, this might have just been a surplus power supply. Now that I look at it. Anyways, this might actually be worth just plugging in. Okay, that capacitor's flat. It's not bulging. Okay. Well, I guess it's probably safe to plug in. I don't see anything amiss. Quite honestly, it would be nice to have a little bench supply. Something tells me that oh, I bet this is supposed to go between ground and negative, probably. So it's not a floating supply. That would make more sense. Well, I think I'll put the top on this, and I'll see if I can find a power cord real quick. And I think I'll just, I'll be brave and yes, so safety first. I will put the top back on this so that if I plug it in and something goes pop, well, then, well, depending on how badly it goes pop, I will either just open the window that is on the other side of my workbench and grab the fan and point it yon way, or I will go running for the rake that I have sitting in the corner. We'll grab the handle of this case with the rake tines. We'll carry it yon way. We'll fumble with the door. We'll eventually open the door and we'll toss this thing outside. How's that? Hopefully it will not go pop that way. Then my basement would smell like burnt voltmeter. I suspect this will probably be a more successful power-up. The pessimist in me is saying to just find the power cord. Or the optimist in me is just saying just find the power cord. The pessimist in me wants to go unlock the doors first so that I don't fumble with them as much. How's that for honesty? And the realist is somewhere in the middle. Okay, I know I've got to have. Oh, there we go. knew I had to have a power cord somewhere. All right, well, I have turned the power off on it. I have turned the current and voltage down as low as they will go. I have the amp switch in low position. It is set for 120 volt operation. I am going to make sure that there is a fuse in it. That was the one thing I wanted to do. Actually, I think the realist in me wants to change camera lenses so that you get a better view of the show. Hopefully there isn't one, but if there is, I'm sure you would like to see it. Well, that screwdriver is not helping me any. Oh, maybe my chip lifter will be able to get. There we go. There we go. Ah, that's actually was helpful. It kind of. Alright, so there is a fuse in it. It is a slow blow fuse. It is intact. There is actually a spare fuse. That's actually probably a good thing. That might actually mean that this is totally fine. Actually, I'm going to swap cameras just so that you can get an overall view of my bench. So I will go to be right back and we'll swap cameras and then I'll be right back. Because no one likes to watch me swap cameras while I'm live. And I'm back. I have power cord. I have turned on my meters, so if this does power up, I can check voltages. I have, possibly the first time in actual use, turned on my meter cam. I do wish my multimeter was backlit, but it's not. So, all right. And I am putting on my safety glasses. So, I am going to plug this in. And seeing as nothing happened, I am going to power it on. And, well, nothing happened. Yay. All right. So it is reading 0 volts and negative 0.3 or negative 0.003 amps. Oh, that doesn't seem right. So if I turn this up, okay. Oh, course fine. So I might need to find the manual for this. All right. Well, let's see here. Up the web browser. This is a Leader 730-3D manual. Well, I'm not the first person that's wanted this manual. Let's see here. Oh, this used to be a $500 power supply. Well, I guess that probably shouldn't surprise me. Of course, no manual. Let's see, that's calibration services. Well, that's disappointing. Is this so old that no one has the manual online? Maybe that's why we scrapped it. No one knows how to operate it. Leader 730-3D. I did type the right part number in. Leader 730-3D. All right, well, let's add regulated DC power supply manual. Wow. Okay. Fine. Wrong one. I guess I will have to try this search engine. All right, well, here's a 733D. That's a data sheet. Controls and indicators. All right. Digital meter shows input voltage or current. Okay. Meter switch selects the output voltage or current for display. Force and fine controls are used to adjust the output voltage level. I am on volts. Do I have to turn the amps up first? I don't know. Maybe output terminals with bus bar for selecting output polarity. Oh, I bet that's the problem. I bet I do need to make sure the bus bar is connected. Okay, well, let's try that. So I want positive polarity. So I'm pretty sure that means I need to tie the bus bar to negative. So because the bus bar is attached to ground, and you can switch it between positive and negative, but you so all right. So maybe now. Oh, I turn volts up. No. So three is the course. I wonder if this requires a complete circuit before it's going to do anything. Maybe I need to. Do I have anything I could wire to this that would complete the circuit but not completely cook? You know, I have a little. I've got a power uh, power resistor. That I found the other day. Okay. No, no. Okay, I found something. Probably not ideal, but I will just make sure the current is set really low. All right. So I have it all set to 0. All right. So I have so gray is positive and purple is negative. I do recommend using better color codes when actually connecting things, but well, beggars can't be choosers. All right. Ah, there we go. I think it. That's annoying. All right. Do I have any voltage? Yeah, I found a little do I have like negative, is that negative 5 millivolts? All right, well, let me just turn this up slightly. Do I even have anything? Ah, nothing. Yep, I've got it wired. So gray goes to brown. The brown's connected to the VCC pin. Yeah, it's like 5.33. I think that's millivolts. Yeah. Ah, it was complaining at me. I think I think it may have been current limited. Maybe now it's 3. Oh, 3.7 volts. All right. Well, that should be 5 volts. Ah, 4.92. Yeah, it's hardly drawing any current. Well, I'm not surprised it's hardly drawing any current because it's it's just a little DS 32 3231, I think. Yep, not surprised it's not drawing much current, but it is getting 5 volts. Or, well, 4.927, so actually the clock is probably running if I had a way to check it. Now, if I just had some voltmeter probes that would actually, I could better measure the voltage. I'm turning the fine adjustment knob on it. Trying to see if I can get it to 5 volts exactly. Oh, well, that's good. And I wonder if I could dial it back down to 3. That's what I need for the Zoxbox testing. Too far. Well, well, I did set it to 3. Well, the display on the front of it says 3.1 volts, but the output is 3 volts. So, well, it looks like I have a working regulated power supply. So I can actually use it to test the voltage controlled oscillator on the Zoxbox. Just need to get some wires so I can plug in the power supply board. But that's promising. So I will set this power supply to the side. I'll leave it where it is because I've got it set to 3 volts exactly. And that way, it'll make it quicker for using it. Set it down there. Yes, I do probably prefer the digital, the newer ones, but hey, I'll use that. It works. Just the display on it seems to be a bit off, but I'll go for what my multimeter tells me rather than that. There's probably an adjustment. If I can find the manual for it, there's probably I can probably calibrate calibrate. In fact, that may be why we scrapped it. It may be we weren't using it. It was too much to calibrate, so it got put in the scrap pile. Sometimes things like that happens. We just had too many. It's an older model. Newer ones are more reliable. I don't know. Anyways, so at least I'll have something to use to test that voltage controlled oscillator circuit on the Xbox. Excellent. So I'm not sure when I'll get back to the Xbox because I've got plenty of other things. The Amiga is a possibility for the next stream because I have the box that is on the bottom shelf of this table is actually Amiga stuff that my friend brought me on Friday. So I had mentioned to him that there was no need to find the ribbon cable or whatever cable for the expansion box because it plugged directly in. I did ask him if he happened across any floppies for the Amiga that I would be interested in them. So I will give you a sneak peek that I do have, among other things, the Amiga Enhancer version 1.2 that apparently came from his attic. So just a sneak peek. And I was happy to see that. Now, of course, I don't know what condition these discs are in, but, well, they are, stuck to the plastic. I can see there's bugs. I mean, these may be in horrible shape because there's bugs on the disc. I don't know. Not sure what condition the disc's in. Looks kind of strange. But anyways, I at least have a potential kickstart disc. The floppy might need to be cleaned. Also possible what I'm seeing is just the fact that these two discs would have been used all the time. Oh, looky here. If your diskettes become damaged or worn out, I don't know if you can see that, but the floppy disk has left an imprint. If your diskettes become damaged or worn out, Commodore realizes that your original Commodore software diskettes may become damaged or worn out through continued use. So we're making it possible to exchange a damaged diskette for a new one. Send the defective diskette back to Commodore with a check or money order for $10 for the 5 1/4 or 3 1/2 diskette, and we'll send you a replacement diskette by return mail within 10 days. So I wonder if Commodore Diskette Replacement, Commodore Service Department, C2655, 1200 Wilson Drive, Westchester, Pennsylvania, 19380, would get me a replacement disk that does not have bugs on it and potentially in it. Ha ha ha. Probably not. I wouldn't even know what is at 1200 Wilson Drive in Westchester, Pennsylvania anymore. Probably not Commodore. I'm not even sure if the original building's still there. But I guess that would have been the location of one of Commodore's facilities. I do remember seeing that they were in Pennsylvania. There's the Amiga Extras, Amiga Basic. Oh, the registration card. Cool. Send this back immediately. Haha. Maybe I should fill that out and send it in and see what happens. No, I won't. It'll probably just come back. Box 651 in Holmes, Pennsylvania. Oh, yeah. Business or placard. They're, I'm for sure that first class permit number 251 in Holmes, Pennsylvania is probably no good anymore. So actually, post office would probably just throw that away because I think that's what they do for business reply mail that is undeliverable. It just gets thrown away. So yeah, not going to be doing anything. But who knows? Maybe the discs work. Could use a vacuum on the discs. But anyways, so I guess this does answer the question: what version of Kickstart was this computer used with? There was another set, but it was 1.1. So it looks like they went up to 1.2. I mean, they may have gone newer, but anyways, what they found. But the cool thing is, there are other things in this box. I actually did pull everything out because I just wanted to check what was in it. But I may, tomorrow on stream, I may open the box and reveal what I have to go along with the Amiga 1000. And I will let you know, spoiler alert, I was very happy with what was in this box. So I know you might have, if you remember, just kind of remember things I was missing when I looked at the Amiga. And then you will probably realize that some of the things that I was missing, I am not missing anymore. So I will, and obviously I just showed you there's a Kickstart disc, but some other things I was missing, I am no longer missing. So I can actually possibly have more fun with the Amiga and get the real Amiga experience. So if you want to see more with the Amiga, then like to give me a subscribe on YouTube or a follow on Twitch. Ring that bell icon so that you get a notification when I go live. Because sometimes I manage to remember to schedule it and sometimes I don't. And you too can see exactly what else I have for the Amiga 1000 that will at least double my fun with it. Or at the very least will let me use it. That's all the spoilers you're going to get until the next Amiga stream. So with that, I'd like to bid you a good evening, and I'll see you next stream. Bye!